Okay, here's the next example for the simplex method section. So we're minimizing g equals 11y1 plus 7y2 subject to y1 plus y2 greater than or equal to 10, 3y1 plus y2 greater than or equal to 15, y1 greater than or equal to 0, y2 greater than or equal to 0. So off the bat, we already do not have a maximize. And if you remember what I said in the last video, the simplex method only works for maximization. This is where we need to make the realization that minimizing g is the same as maximizing negative g. So what we do is we define a new function and we let it equal negative g, which is 11y1 plus 7y2. So if we distribute that negative, our new function now is f equals negative 11y1 minus 7y2. So there, we changed it from a minimization to a maximization. The next thing is that these had to be less than or equal to, these had to be greater than or equal to. So our non-negative constraints are correct, but we have to flip those. Well, the easiest way to flip an inequality is to multiply it by negative 1. So we're going to take negative 1 times the first inequality and the second inequality. So we get negative y1 minus y2 less than or equal to negative 10. Negative 3y1 minus y2 less than or equal to negative 15. So now we have maximization less than or equal to non-negative constraints. We're set up to start our tableau. So we need some slack variables first. So we get negative y1 minus y2 plus s1. Because we have two inequalities, there's going to be an s2, and then we have an f. So then that would be equal to negative 10. The second inequality, negative 3y1 minus y2, no s1, or we're going to have an s2, and no f. And then our objective function, we have to take these terms, move them over there, so we'll add them in this case. So that's 11y1 plus 7y2, no s1, no s2, and 1f. And if I move those over, we're left with 0 on the right-hand side. So our initial tableau is negative 1, 1, 0, 0, negative 10, negative 3, negative 1, 0, 1, 0, negative 15, 11, 7, 0, 0, 1, 0. We got a separator for the constants, a separator for the objective row. A nice thing to keep in mind to make sure that you set this up correctly, there should always be an identity matrix right here. So notice how there's ones on the diagonal, zeros everywhere else. If you don't get the identity matrix, double check and make sure you did things correctly. Okay, so we're ready to go. This time, we do have negatives right here, so we can't skip phase 1. So we have to start with phase 1 here. So the first step of phase 1 is you just pick one of these negative values. And it doesn't matter which one. Where in phase 2, you have to pick the most negative. Phase 1, it doesn't matter. So what I'm going to do is I'm just going to pick this negative value, which means that first row is my pivot row. Or no, that's not our pivot row yet. Sorry, I'm getting ahead of myself. Then you have to find another negative value in that row. So either the negative 1 or the negative 1. I'm just going to choose this negative 1. Again, it doesn't matter which one. That now is our pivot column. Now that I have the pivot column, I'm going to take our quotients. Now before, we were looking for the smallest non-negative quotient. The reason why it's worded as non-negative is you can use 0. Here, we're looking for the smallest positive quotient. That means you can't use 0. It needs to be a positive number, can't use 0. So we get negative 10 divided by negative 1, which is 10. Negative 15 divided by negative 3, which is 5. That's our smallest positive. So there's our pivot row. So there's our pivot entry. Let me pull up the calculator. Make sure I got them incorrectly. Yep, looks like I typed it correctly. So now I'm going to go negative 1/3, row 2, replace row 2. So negative 1/3 times row 2, replace row 2. Now we're not done with the pivot step because all we did was make our pivot entry into a 1. Now we use that 1 to annihilate the rest of the column. So it's going to be 1 times row 2 plus row 1, replace row 1. And negative 11 times row 2 plus row 3, replace row 3. So we're adding 1 times row 2 to row 1, row replacement. Then we're adding negative 11 times row 2 to row 3, row replacement. So we get 0, negative 2/3, 1, negative 1/3, 0, negative 5, 1, 1/3, 0, negative 1/3, 0, 5, 0, 10/3, 0, 11/3, 1, negative 5, 55. So there we go. We did our first pivot step. But now, are we done with phase 1? No, because we still have a negative value over here. So I use that negative value. Find another negative value in that same row. I got two options again, the negative 2/3 or negative 1/3. I'm going to do negative 2/3. Now this one isn't a rule, but if you have a decision between a regular variable and a slack variable column, I usually choose the regular variable column. Okay. And now I need to do the quotients of this and this. So we get negative 5 divided by negative 2/3, which is 7.5. And we get 5 divided by 1/3, which is 15. That's the smallest positive. So that means this is our pivot entry. So to make that into a 1, we take negative 3/2, row 1, replace row 1. Negative 3/2, row 1, multiply. I'm not done with this pivot step yet, because all I did was make it into a 1. We still have to annihilate. So there's my pivot entry. So negative 1/3 times row 1 plus row 2, replace row 2. And negative 10/3 times row 1 plus row 3, replace row 3. Okay, so now we're done with phase 1 because there's no negatives right here. So we move on to phase 2, which means to look for negatives down here. This corner value is allowed to be negative, but everything else has to be positive. They're all positive, so we're done with phase 2 now as well. And we can read the solution. Now, I do want to say there are going to be problems where you have to do both phase 1 and phase 2. They're not all like example 1 where we just did phase 2 or example 2 where we just did phase 1. They will be mixed, and I will do examples in future videos for that. So now let's look. This was our y1. This was our y2. S1, S2, F. And then this was our constant. So y1 is 5/2. Oh, let me switch it. Get rid of that calculator. Y2 is 15/2. And F is negative 80. And then S1 equals 0 and S2 equals 0 because they have a bunch of numbers in their columns. Now don't forget, the point of this problem was to minimize G. What we've just done is maximize F. But F is negative G. So if negative G equals negative 80, that means G is positive 80. So G has a minimum of 80 at 5/2, 15/2. And that's how you do a minimization problem. Now I do want to show you what this does graphically. So let's go back up. Let's read the solutions off here. S1 would be negative 10. S2 would be negative 15. F would be 0. Where y1 would equal 0 and y2 would equal 0. And then this one, we have y1 equals 5, and S1 equals negative 5, and F equals negative 55, while y2 equals 0 and S2 equals 0. So again, we did this with 2 pivots. So again, we started at 0, 0. Then we went to 5, 0. And then we went to 5/2, 15/2. So let me bring up Desmos to show what's going on. So we start at 0, 0. So like I said, that is not part of our feasible region. So what phase 1 is doing is it's going to move us to another corner. And after the first pivot, it moved us to 5, 0, which is right there. Now, the reason why we didn't do phase 2 yet is because we still are not touching the feasible region. So that's why we're still in phase 1. So then we have to pivot again. And with the next pivot, it brought us to 5 halves, 15 halves, which is right there. And now we're touching the feasible region. This is where we enter phase 2. But since that was already the optimal solution at that point, that's why we didn't have to do any of the steps of phase 2. So that's what happens. Phase 1 brings you from 0, 0 to touching the feasible region. And then phase 2 rotates you around the feasible region until you get that optimal solution. So here are the basic maximization and minimization problems.